The two that we'll be looking at right now are going to be apps, app.js, which points the only thing inside of app.js is a reference. So this is a import or require statement that references the file download simulator, which is inside of modules. And JavaScript is a bit weird in that when you import an external library or a piece of code, external piece of code, that piece of code, you don't put the extension, put.js. And this, in fact, is one of the sort of things that the creator of Node.js sort of regretted. So it's weird, but it's stuck that way. Okay, so look, this download simulator file is what we're going to be working with today. Okay, and inside of here, the code is actually fairly complex. Okay, it's got a lot of dense code inside of here. Now, for us today, we don't need to know the specifics of this code. Okay, we can treat this code as a black box. The only thing that we need to understand is going to be the documentation of the code. Okay, we don't need to know specifically how this code runs. We can just we're just using it to in this case the file name is called download simulator. We're probably simulating some download, but we're only using it. We don't need to know how the code is run. There are going to be specific instances where I reference like individual functions inside of here. Okay, but we don't need to know how the entire thing as a whole works. Okay, instead what we need to know is the documentation. Okay, so good documentation is going to be very helpful, even if we are not writing the code inside here, if we're just using it. Okay, so let's read what this documentation does. So download simulator, okay, takes in a file, time, seconds, and failure chance. Okay, so it has 3 parameters. It simulates a download, either synchronously or asynchronously. So we are given the option to run this program either synchronously or asynchronously. That's how we're going to sort of cover this topic. We're going to be doing something synchronously, and then we're going to be doing it asynchronously. We'll see the differences. And if it's successful, it creates a file with the user specified file name and runs callback. Okay, so we don't know what callback is yet. We'll come back to that. But it says that it's going to take the file that the user specified. So that's going to be this parameter over here, the file that they specified. And it's going to create that file. So it's going to create that file. So if I say something like 1.txt, it's going to create 1.txt. If it fails, no file is created. Callback runs and contains an error object. Okay. And again, we'll explain what this is in a bit. The next are the inputs. Okay, so this thing accepts 3 inputs. And these 3 inputs are encapsulated inside of a single object. So it's a single object destructured into 3 components. Those components are file, time, second, and failure chance. So essentially, you can think about this a little bit like parameters. Okay, parameters, file, time, second, failure chance, but they're wrapped inside of a single object. And the reason that this is done is to make the code, this is just one style of writing code that I prefer using a parameter list. So I don't like writing my functions. I don't like writing my functions like this, where there's a list of parameters. Instead, I prefer to have a single object called spec, and then I do a destructuring of that object to pull out only the properties that I like. Okay, so for instance, this is equivalent to me saying let file equals spec.file. Let time second equals spec.timesecond. And on your copy, don't change these because I'm just going to undo all this. Let failure chance equals spec.failure chance. Okay. So the nice thing about this is that, first of all, the order no longer matters because the order in which I define a object doesn't matter. So if I do time seconds first, and then file next, and then failure chance next, it doesn't matter. I can omit specific components. If I say that, oh, there's no time seconds, okay, that might break my code down here somewhere, but it won't fail up here. And if I add additional things, okay, if I add additional things, like if I add let's say I add a speed over here. If I add speed over here, then if I'm not using speed inside of this code, I can just ignore it. Okay, there's no problem because the order of these parameters doesn't matter, even if I put it over here. Now there is some drawbacks to using this. The drawback is that I think the drawbacks are pretty minor in my perspective, but they will appear today. The drawback is that when I use this function inside of app.js, when I use this function, I have to use these names, these property names. Okay, because how this is accessing them, it's doing spec, it's equivalent to spec that file. And if I give it a object that has a property file1 over here, if that's the proper name, then it's not going to find spec that file. It's gonna look for spec that file. It doesn't exist because it's called spec that file1. So that's the drawback, that because you no longer use the order of the parameters and you use the file name, you have to be careful that that file name matches. And since I'm the one creating these files, then it's a really minor issue because I will always force them to be consistent. Anyways, so look, we're going to be using this function download similar. We'll go back to the specifications as we learn more about it. But in short, this essentially will create an object that the goal of this function in the long run is to simulate some type of download. Okay, so I'm going to specify a file. Let's say that file /file_01.txt. And time seconds will be 2 seconds to download this file. And then the failure chance, let's say 0 for now. Okay, so there's no chance for failure. We'll discuss what failure chance means later. Okay, but for now we'll say that the download succeeds every time. And so what does this return back? Okay, what does this return back? Let's look into the code a little bit. Okay, so we can see that this is very similar to our dog function that we discussed last class. So we have a outer function over here, and inside of it we have sort of instance variables, and then we have this function. We have function download sync, we have function download async, and we have function finish download, and then we have a return statement. Okay, so this is what we care about because we're calling the function download simulator, so it's got to return us something. And what does it return us back? It returns us back an object that contains two functions, download sync and download async. So I'm going to call this object my downloader. And let me just print it out. I just want to know what this object is. Okay, so if I run this, okay, so if I run this, it's going to tell me that the my downloader object is an object. Okay, so it tells us it's an object because there's curly braces that denotes that it's an object. And this object has two properties or two keys. The first key is called download sync. Okay, so I can say my downloader dot download sync. Okay, and I can also say my downloader dot downloader async. Okay, these are the two keys. And what are these though? Well, this curly F over here, this colon denotes the value, and the curly F denotes that this is a function. And the same with download async. So both of these are functions. Okay, so this is how I'm going to be able to download stuff. Okay, if I want to download something, I need to choose where I'm going to be downloading it, synchronously or asynchronously. Okay. And so if I call my download async, I'm going to download something synchronously. Okay. Now let's go back to the specification. Okay. So the public methods that are available to me, we already know that they are download sync and download async. Okay. There are also private methods here. The finish download function is a private method. Me as someone who's using this downloader, okay, I don't know how this works. But I can't call this finish download function because it was never exported out. Okay, it's something that is private. I can use it inside of here. You can see over here it's used twice. But me as the person writing app.js, the only thing that I can call is download sync and download async. Okay, so that's sort of private. So the public methods, in contrast, are the two that I can actually call. Those are download sync and download async. And there's a parameter that is required from each of these functions. And that parameter over here is called callback. Okay, so callback is a function that is required for asynchronous programs. And over here, this one's synchronous. This function is synchronous, but I wanted to model how an asynchronous program would work. Okay, and effectively what an asynchronous callback does is when that process finishes, when that task is complete, whatever that task might be, in this example, it's downloading something. That may take a couple of seconds, okay? Other examples might be something like reading a file from disk or making a DNS request, okay? When that task is complete, what do I do afterwards? Okay, that is what the callback. And that specific task, okay, so what is the data type for a task? What do I do afterwards, okay? That's a task. The data type for that is function, okay? So every time you're trying to do a callback is always a function, okay? Because it's a task of what you want to complete afterwards. So I'm going to give it a function. And I'm going to keep it very simple. I will just print out file download success, succeeded. And I'll put the file name. Okay, so what this is going to do, it's going to download the file, file01, and then when it finishes, it's going to print out the message download succeeded. Now, for synchronous tasks, we're going to find out that this callback is largely unimportant because the reality is, what do I want to do when it's finished? Well, that's easy. I can just put it on the next line. I can just say all downloads finished. And that's because this line 10 is blocking. Nothing else can occur. Nothing else can run until the download finishes. Okay, I can't do anything else until line 10 finishes. And so the only way for line 10 to finish is for me to get all the data from the internet or wherever this download source is from. So I don't really need this if it's synchronous, but when we move to asynchronous code, it's required. Okay, because you're doing multiple tasks at once when you're doing something asynchronous. You're downloading a file and downloading 100 other files at the same time. Okay, so when it finishes, something else might still be working. The timing of those tasks are not guaranteed. So it's not going to automatically just move to the next line. Okay, but again, for this example, what we expect what we expect and what we see are going to be the same. So what we expect is that it's going to download a file, it's going to print out the message download succeeded, and then it's going to print out all downloads finished. Okay, so let's run that. Oh, I should have got rid of this. I don't need that line. Okay, so ignore this line that prints out the function that I just removed. But it says download succeeded, file01.txt was ran, and you can see that this file indeed was created. Okay, that sample download. Okay, so I don't need that. And then it says all downloads finished. Okay, so let me go through what's happening under the hood. Okay, so the JavaScript architecture has several components inside of it. The Node.js architecture. Node.js architecture. And the two that are going to be important for us today are going to be the V8 and libuv. Okay, so this is the sort of interpreter and the compiler that run our code. Okay, so this sort of runs our code. Okay, and libuv provides asynchronous support, supports asynchronous code. Okay, now both of these are actually written in C++. Actually, I'm not sure libuv. It might be C or C++, something like that. Okay, so these are very low-level libraries, and these are very old libraries as well. Some of these were made in like 1990s. Okay, so some of these libraries over here, most of these low-level libraries are written in C, C++. Where we're closer to the hardware, we can do things like system calls. Instead of JavaScript, you can't do these sort of system calls stuff. Okay, you can't do these very low-level calls like C++ again. So how do we interact with them? We have things called bindings. Okay, Node.js has these things called bindings, and so when we make specific API calls, okay, the bindings essentially translate our JavaScript code into specific calls, system calls that these programs can understand. So this acts as a layer of translation. So it's like a translation layer. Okay. So what is libuv? We know that libuv provides us asynchronous support for asynchronous code. Okay. And in fact, we'll discuss what libuv is in a second, but let's see what's happening inside of our code. So inside of our code, we have our main program. Okay, we have our main program. And then inside of our main program, effectively, it's going top down. So it's doing line 3, it's assigning this to a variable, line 4, line 5. Line 7, it calls the function download simulator. Okay, and then this is where some work actually occurs. So this is where we call download sync. So in fact, let's put that over here. So I'm going to abbreviate it DS, download sync. Okay, and so this is going to download a file. And while it's downloading the file, I can't do anything else. I can't do anything else. I can't do the next line because it's working on this download process. And this is what it means to be synchronous. It means to be blocking. Okay. In that V8, okay, V8 is single-threaded, which means I can only do one thing at a time. Okay, V8 is single-threaded. And so if I have something like over here that says download this file synchronously, okay, then it's going to be busy doing that. And that's going to wait 2 seconds to complete this task. And then when it finishes, then it executes this function. This function doesn't have a name. Let me give it a name. I'm going to call it finish download. Okay. So it doesn't need a name, but it's going to be helpful to us to give it a name. So this one finishes. We call it finish download. Okay. That prints out this message, download succeeded. Okay. And then that pops off. Okay, we're done with this. That pops off. Then this function download synchronous also finishes. Okay. And this pops off. Let me see if I can just erase the D and erase the S. Okay, that's good enough. So that pops off. And what goes on next? What goes on next? The next thing that goes on is line 15, console.log, all downloads finished. Okay. Console.log, etc. Okay. So that's how we get this output. Okay. So effectively, this code runs top down. That's what it means to be synchronous. Okay. Runs top down. This is the first thing that executes. I'm stuck inside of here. When this finishes, this function gets called. And then when this finishes, I'm finished with this. I exit, move on to the next line. So this is pretty obvious. Let's see. Before we move on, right? Before we move on to the next one, I'm going to introduce the error failure. and let me bump it up to 100%. Okay, so we have a 100% chance of error in this now. Okay, so I just changed this from 0 to 1. This failure chance is accepted as some decimal value. And if I run this, in fact, let me actually, no, that's fine. Let me run this. So there's no files over here right now. Okay. And because it's a 100% chance of error, and the documentation says if there's an error, no file is created. Okay. Then no file is created, so that's correct. Okay, but our output still says download succeeded. That's because we didn't detect the error over here. So how do we detect the error? Let's go back to our documentation over here. Okay, so we know that if it fails, no file is created, callback runs and contains an error object. That's what it's telling us. So the callback runs, okay, and it contains an error object. So that's what this means over here. Over here we have download sync callback, and then callback over here is going to contain an error, and it says that that error is returned if the download fails. So essentially it says that we can assume that there's an error object. Okay, we can assume that there's an error object. Okay, so we can assume that there's an error object, and then because we can assume that there's an error object, all I have to do is detect for that error object. If error, okay, if error is not null, then let's print out the error. Okay. And so this error object is provided to us by download simulator. Okay. So over here, there's a piece of code that says if random number, so generate a random number, is less than failure chance, so generate a number between 0 and 1. If that's less than failure chance, there's no way that it's less than 1. Okay, there's no way a number between 0 and 1 is less than 1. Then execute callback. So we always get this line executing, and it says run the callback and give it this object error. Okay, new error, download failed, file name, failure chance. Okay, so if I run this now, when I do console.log error, this will always print out the error, just because my failure chance is 1. Okay. So you can see that I still have some bugs over here. It says I'm missing an else statement over here. So I do get the error, but I also get download succeeded message, which I don't want. There you go. Okay. So error downloading this file. So this file is ignored, and then all the files that were supposed to be downloaded either errored out or finished. And so I'm going to just leave this here because we need it for the next demo. Okay. So actually, when working with synchronous applications, downloading one file, when working with synchronous versus asynchronous, there's very little difference when you're only downloading a single file. The differences appear when you're downloading 2, 10, 100 different files. So we're going to download 2 files next. Okay, and then we'll do it synchronously, and then we'll do it asynchronously. Okay, so to download a second file, I'm just going to copy this entire block of code. Okay, most of this stays the same. Okay, so we have file. I'm going to change it to file 2. I don't need to declare it again. I'm just going to change the value. And let's say that the first file takes 10 seconds. And the second file takes, and we'll change the failure chance back to 0. Okay, so I'm going to create a new variable, myDownloader2. Okay. Just because I think I could reuse this one, I just don't want to. Okay. And myDownloader2.downloadSync. is going to be called with this function, finish download, over here. Okay, and you can see already that over here I have some code that's duplicated. We'll probably try to extract it out, but for now we'll just leave it. Okay, and we have the same code for the error, if error, print out file. Okay, and for when we run this synchronously, this will be fine. Okay, synchronous behavior we understand. We took 111, we took 211, we took 313. Synchronous behavior is easy to understand. It's just top down. What's most likely going to print out is, because there's no chance of error, it's going to print out download succeeded, file 1. Download succeeded, file 2. All downloads finished. Okay, this is what we expect. Okay, and in fact, this is what you're going to get. So let's run this. Okay, so this is taking 10 seconds to download the first file. Okay, and then that file finishes. And then the next one takes 2 seconds. So that download finishes. So in total, the minimum amount of time it needs to run this program is going to be 12 seconds. Okay, so now you see our first limitation of synchronous behavior. Well, because of the fact that I have to spend 10 seconds downloading this file before I can do anything else, I can't even download the second file. I have to wait for that first one to finish. Okay, this is the limitation of doing something synchronously. That if I'm doing this synchronously, this is blocking. This is blocking anything else from entering this stack. So effectively, even if file 2, even if I shrink this down to 0 seconds, right? Even if I shrink this down to 0 seconds, I can't start it until file 1 finishes. Okay, I can't, even if this is supposed to be finished instantaneously, because synchronous behavior locks me inside of this loop, this piece of code over. Where is it? Yeah, it locks this block of code over here, and I can't exit it. Then I'm stuck in here for 10 seconds until it finishes. Then I can move on to the next block. Okay, and this is what we expect for synchronous behavior. This is all our code up until now has behaved like this. Okay, and when we try to have this behavior of downloading 2 files at the same time, we're going to see that everything that we previously understood very well starts to fall apart. Okay, so before we do that, let's clean this code up a little bit. This is not going to change the behavior of our code, but it'll make it a little bit neater when we do. So I'm going to move this function finish download to the top. Okay, I'm going to move this function finish download to the top, and then I'm going to replace the function call with just the function name, which we know we can do already. And so this will essentially be file 1's download. Okay, so we have our what to do afterwards. We have our file 1, 10 seconds, failure chance, create the download simulator object, and then use it to download synchronously. And then over here, I'm going to do the same thing. Instantiate the file, the time seconds, the failure chance, the my downloader object, and then I'm going to use the download sync over here to call finish download. Okay, so this is a cleaned up version of that code. Okay, and we'll run this. We'll see that it's the same. Let me change this back to 10 seconds and 2 seconds. Okay. And so let's run this. There should be no problems with this. All we did was move this function out into here so we can reuse it. Okay, so you can see file 1 was created, then file 2. And again, this is guaranteed. Okay, this ordering it must be like this because this is running synchronously. And the program inside of here, download sync, is blocking anything else from executing. So next we're going to run this asynchronously. Okay? And so to do that, all we have to do is change download sync to async. We add the A in front. And essentially what we want to do, what we want to happen is that we want file 1 to download at the same time file 2 does. And then when they're both finished, then we can print out the message, all downloads finished. Okay? And what we're going to see here is this is not what's going to happen. Okay, I changed this to asynchronous. So they are going to download essentially parallel if we look at the output over here. And in fact, let's increase the amount of time. Before we had to do 10 seconds and 2 seconds. Let's do 10 seconds and let's do 15 seconds and 10 seconds. Just to show that it should take a substantial amount of time. Now, if I was doing this synchronously, the amount of time would be 15 plus 10, which should be 25 seconds. But if I'm doing it asynchronously, okay, because it should take the larger of the two. Okay, it should take 15 seconds to complete both, because it's working on both these tasks at the same time. So what I want you to pay attention to as this program runs is the debug console. Okay. So what I want you to pay attention to as this program runs is the file output first. Okay, pay attention to file output, and then afterwards we'll look at the debug console. So what I expect is file 2 to finish first. So file 2 should be created first, and then file 1 5 seconds later. Okay, because this one finishes faster. Okay, so file 2 should appear first, then file 1, and the output is going to surprise you. So not this, but this one will work normally. This will work, but the console output will surprise you. So as I run this, focus on the files that are created first. Okay, so this program is now running. And the first file that's created, let's see, it's taking 10 seconds. So the first file that's created is file 02. Okay, that's expected. And then the next file that's created is file 01, which completes it. Now let's look at the debug out console. Okay, so that was expected because we wanted them to run in parallel. But what's unexpected is the debug console. The very first thing that it prints out is all downloads finished. And then it prints out download succeeded, file 02.txt is printed out. And we see this number 2 over here. This means that if the same exact output gets printed, then it just groups them up. VS Code will group them up for you. Okay, but essentially it's saying that the same thing printed twice. And this is really strange because when we did it synchronously, it would print out file 01 over here. Okay, now what's happening is that this variable file, it got changed. It got changed before this function had a chance to print it. Okay, and the first thing that may come to your mind is that, oh, this is a race condition. Okay, if I change these numbers a bit, then I'll get a different output. And the answer is no, it is not a race condition. No matter what numbers you set for time seconds, this output will always be the same. Okay, so before we do that, let's also look at the all downloads finished. Okay, so I'm going to run this again, and this time I want you to look at the console. Okay, I want you to look at the console. And what you're going to see is that this message, all downloads finish, it will print before any files get written. Okay, so in fact, I'm going to bump this up to 15 as well. Okay, so both of them will take 15 seconds. And before any files get written at all, it will print out the message, all downloads finished. Okay, so it prints out all downloads finished, and none of the files have been created yet. Okay, so we still have to wait maybe 10 or 15 more seconds for these files to be created. And then as these two files are created, then we get the message outputs. Okay, so that is also really strange. This executes before the files even start to be created. So in fact, this is lying that the files have been finished, because they aren't. Now the output in terms of the files that were created are correct. Okay, these are being created in total 15 seconds. Okay, the larger of the two. It's not combining it and completing it in 30 seconds, which was what we had before. When we run it synchronously, this runs, that takes 15 seconds, then this runs, it takes 15 seconds. When we're doing asynchronously, they effectively run concurrently. This runs and this runs at the same time. Okay, but we were trying to still make sense of what's happening over here. Why does this print out all downloads finish? Why does this print out download succeeded file 02 twice? Okay, and it's because of how the asynchronous architecture has it. So we're going to look back at over here. So in our synchronous example, we never use libuv. In our synchronous example, we only use V8 the whole time. V8 was what was downloading the program. Everything is single threaded. Everything runs inside of here. So if we're doing synchronous, we never use libuv. So we're gonna look at a asynchronous example where we do use libuv now. Okay. So let's look at what's happening. So again, we have our main program. We have a program. And the main program, inside of it, eventually it calls a function, download asynchronously. Okay, it calls a function, download asynchronously. And so what's going to happen with this function, download asynchronously, is the following. What this does is it doesn't download the program. Okay, when we had download synchronously, okay, this will download. Okay, this will do the program. It'll do the download. Okay, it'll accept the download. Okay, this doesn't do that. The download asynchronous, it doesn't do the work. All it does when we're doing an asynchronous call is it schedules tasks to be completed by the worker thread. So it doesn't perform the download, it just schedules a task to be completed by one of the worker threads. Okay. And so how it does this is it's going to take that task, let's call it task 1, and it's going to put it into this task queue. Okay. So it doesn't do the download. You can think about it as when we did our discussion of eager versus lazy. Okay. And that download synchronous is very eager. It would do the download itself. Okay. Whereas this is lazy. It's not going to do the download. It's going to schedule that download to be completed, and it's not going to be the one who does it. It's going to schedule it to one of the worker threads inside of libuv. Libuv provides us a pool of worker threads. Okay, so before we talk about how these worker threads move, let's see what happens next. Okay, now because all this does is schedule a download, it's done. Okay, it's done. So that was line 14 in our code. Okay, it schedules this task to be done. So what happens next? What happens next is line 15, then 16. What does line 16 do? Line 16 changes the variable of file to file 02. And that's why we get this as the output, because this variable file, it was changed. It was changed before this had a chance to execute. Okay, so the next question you might be, well, what if this finishes really fast? What if I change this time to be 0? Change both of them to be 0. And it doesn't matter. There are actually no race conditions inside of this program. No matter how you run the program, the output will always be all downloads finished, then download succeeded file 02 twice, even if we change time seconds to 0. So there are no race conditions inside this program. Okay, so we see the outputs is still the same, even if we change the time to 0. So what's happening is the following. Okay, so after it schedules the task, it doesn't do the download. So it immediately moves to the next step, which is to change the file, change the time seconds, change the failure chance, and then it declares a new variable, my downloader 2, and then it schedules another task. Okay, we schedule another task, my downloader 2. Okay, so that goes into a task queue. Okay, and then finally what it prints out is all downloads finished. That's why we print it out over here. Okay, and now the question is, how do I prove that this is what prints out? What happens if this task queue gets completed really fast? Okay, we'll assume that the task queue gets completed really fast. So what happens? So your computer, okay, your computer has a pool of worker threads assigned to it by libuv. So if libuv is running, it has a pool of worker threads, and the number of threads that you have is constrained by your hardware limits as well as your software limits. So it's typically some factor of the number of cores that your CPU has times the number of threads that your operating system allows it. So if you have a more expensive computer, you probably have more threads. Anyways, so typically you'll probably have a couple hundred threads inside of your computer, but they are somewhat limited, and these threads can work in parallel. These threads can work concurrently. Okay, so what's going to do is when a thread is available, okay, so let's say that this thread is free, then it's going to take the first element inside of the task queue and it's going to start working on it. It's going to say, okay, I'm going to work on task 1. Okay, and then maybe a different thread, it's free, and it'll say, okay, I'll take the next one, which is 2. Okay, and it's going to work on these tasks as fast as they can. Okay, maybe sometimes it's fast, maybe sometimes it's slow. Okay, and let's say that task 2 completed first. Okay, if task 2 completes first, okay, then the following happens. The worker thread will then take the callback. Okay, now every time we call this function, every time we call a asynchronous function, the requirement is that you must always give it a callback. Almost all asynchronous functions require that you give it a callback. And that callback is what happens when that asynchronous task completes. So in this case, I want it to call finish download. Okay, when it finishes, I want you to call finish download. Okay, so I'm gonna put finish FD for finish download. I'm gonna put 2 over here to specify that this was the worker thread 2's the task number 2 that was finished. So when this worker thread finishes, it's going to put it into the event queue. And so this is the actual queue. So this is the head of the queue. This is the tail of your queue. And we know that the queues work in the first thing that is put in is all comes out. Okay. And maybe eventually this one also finishes. Okay. Okay. And let's assume that this process is instantaneously. So meaning that as soon as this line over here, line 20, runs, as soon as this line 20 runs, then the task is already in the event queue. Okay. Now the question is, what controls when a event queue task gets moved into the program memory, into V8? And what controls it is the event loop. The event loop controls what goes into V8. So how does it decide? It decides on the following conditions. The event loop will continuously monitor V8. So it's going to monitor V8. And it's going to check to see, is this empty? Okay, is there anything still inside of here? And currently it still has stuff. It still has the main program. Okay, but if it ever becomes empty, if it ever becomes empty, then it's going to pull the first task from the event queue and move it into V8. Okay, so if the answer is yes, then move the head of V8 of the event queue to V8. And if the answer is no, then just gonna busy wait. Just wait a couple of cycles and check again. Okay, so what does this mean? This means that in order for this function finish download to execute, this whole program has to finish, which means that this line 22 is part of the main program. Line 22 must finish. It must execute. So even if we assume that this finishes instantaneously, it still won't go into the main program, because the main is still inside of here until every single line of code is executed. So this will always print first. This line of code will always print first. Okay? And then when that one finishes, then this pops off, the main pops off, and then we can start moving these into V8. Okay, and that's why there's no erase condition here. No matter what, this first program executes, and then these two outputs. So the next question that we might ask, okay, we're done with this. I'm going to hide this for now. Okay, in your first assessment, it's going to sort of test you on how to actually get this to be correct. Okay, but let's hide this for now. And instead, our next question that we want to tackle is, why does it print out file 02 twice? Okay, why does file 02 get printed out twice? Okay, and the answer to that is that because this variable file over here, it still has scope. Okay, this goes back to our discussion of closures. Okay, and so by the time this executes, the variable file has been changed. Okay, it's been changed to file 02, and we already know that a closure is not a snapshot of a particular program at any given time, but a linkage. So if we change it later on, then every time we use it, it's going to use that same variable. Okay, and then in the discussions, I saw that someone wanted to change the file names to another variable name, and this is a solution. This is a possible solution, but it's also a solution that doesn't scale. Okay, meaning that this will work. I'll need to change the entire program to do this, and this is in fact something that we will do. But we're going to see that even those changes that I make, they're going to be very painful to make, and it's also something that when you look at it at the end, you're going to say that this doesn't scale. If I need to download 100 files, it doesn't work. Okay, so let's do that. So I think the suggestion was, let's call it file 2. Let's call this one file 1 and file 2. Okay, so I'm going to call this time seconds, 1 failure chance. Let's just change all the variables since we're changing some of them. Okay, file 1, failure chance 1, file 2, failure chance 1. And so the first pain point is that this download simulator, it requires that the names matter. Again, remember, it's going to go inside of here. It's looking for a property called file, not file 1. So if I put file 1 over here, it's no good. So I have to put file 1 over here like this. Take file. What is the value of file? It's going to be file 1. I'm going to have to repeat this for all of them. So already the code is getting very, very messy. And then I'm going to repeat this for file 2. Okay, so that's our first pain point. Next pain point is that over here we have, this one should be file 1 and failure chance 1. Yeah, there we go, we fixed that. So the next pain point is that we have this function finish download over here, and the finish download, it uses the variable file. Okay, but we don't have the variable file anymore. We have file 1 and file 2. So which one do we choose? If we choose file 1, if we choose file 1 over here, just type it. If I choose file 1 over here, then this works, but this doesn't. Okay, because it's just going to print file 1 twice now. So what does this mean? It means that, well, I got to have 2 of these functions now. So I need one for file download 1 and one for file download 2. Okay. And finally, after all these changes, we have 2 functions, we have 2 files. Now they are completely decoupled. Now this will work. Okay. And let's change the time to math.random. So I don't know which one will finish first. And let's multiply by 5. Okay, so this works. This works in the most ugly code sense that it's technically correct. But do note, like on the test, I'm not going to ask you to write 5. I'm not going to ask you to write 2 files. I'm going to ask you to write 100 files, and then all of a sudden, this doesn't work anymore because you're not going to be declaring 100 functions. Okay, so we're going to run this first to just show that it does work, and then we'll look at the actual solution. Okay, so file 1 finishes. We still have an issue. It's printing out file 1 twice. Oh, I didn't change the variable over here. This should be file 2. There you go. Let's run this one more time. All right, finish download 2. Should call finish download 2. Okay, so download 2, then 1. 2, then 1. 2, then 1. Okay, finally, 1 and then 2. Okay, so the order is not guaranteed. Okay, depending on the random number that's generated. One will download faster than the other. Okay, so it's no longer guaranteed, but the total amount of time spent downloading these 2 should be about 5 seconds if we assume that the downloads are actually instantaneously. Okay, and that I'm doing this process. Well, it should be at most 5 seconds. If let's say the first download takes 1 second and the second one takes 2 seconds, then we're substantially less. But it shouldn't be. If this was synchronous, then we could wait of up to 10 seconds because this could take up to 5 and then this could take up to 5. But asynchronously, we do them sort of concurrently. Okay, let's look at the actual solution for how to solve this. And so the solution to solve this is to leverage closures. The reason why the file changed was because it still had scope, meaning that if I, let's say, keep on working down here, can I say file 1 or file 2? Yes, I can still reference it. This still has meaning. Okay, meaning that if I change the value somewhere, then that change persists. Okay, but if I have, let's say, a set of curly braces, okay, let's say from a function or something, and I had some variable x inside of here, outside of this function, can I use that variable x? No, I should not be allowed to. Okay, so it has no meaning, but there are exceptions when we use closures. When we use closures, there are ways for us to preserve that access. Okay, so that's what we're going to leverage. Okay. Okay, so we're going to have 100 files. Const files equal 100. And our failure chance, we'll set it to be, we'll set it to be 0.1. Since we have 100 files, let's say that one of them fails every 100 or so. Okay. So over here we have a loop. We have a loop construct. Okay, we have a loop construct, and we have a variable I over here. Okay, meaning that we know that if I try to use I outside of here, okay, this is going to fail because I has no meaning outside of this loop. Okay, as well as if I declare some variable x inside of here, outside of this loop, it has no meaning. Okay, so this is essentially what is going to allow us to run our code correctly. Let me. Okay, so I declare a variable I equals 0. It's going to go up to the file, so it's going to go up to 100. I think it's one at a time. I declare a time seconds inside of this loop. Okay, I didn't declare it outside of here because I want a new time second every time. If I declare it outside of here, it's the same random number every time. Okay, I want a different random number every time. Okay. Next, I specify file. File is equal to the directory files. Okay, so I'm trying to generate this style of file for 99 files, and so that's going to require that the directory and then the file name. So the file name is the word file underscore, and then we're going to use the string.pad start we're going to convert the number to a string. So 0 becomes 0, the string version 0. And I'm going to pad the front of it. Okay, we're going to use this pad start function to pad the front of it with the character 0 until it reaches the length of 2. Okay, so the number 1 becomes the string 01, and the number 10 becomes the string 10. Okay, and then that gets attached with the .txt, and so that's going to be our file name. And then we're going to create a download simulator, okay, based off of that file name, time seconds, and failure chance. And we're going to run this. We'll run it first synchronously, okay, just to show you the difference, and then we'll change it to asynchronous, okay, to show that it works. And then we need a callback inside of here. What do we do after the download has finished? Okay, what do we do after the download is finished? Well, we know we get an error. Okay. In fact, we'll call this finish download. Finish download. And there you go. Okay. So when we finish download, if there's an error, print out the error. Otherwise, print out this file has been finished downloading. Okay. So something similar to what we had previously. And what I'm going to say over here is, well, when we do this asynchronously, that this is how you generalize it. Okay. So this one is running synchronously, but let me change it to async, and then well, just pretend that it's async, okay? But I'll change it back to synchronous when we run it. But if it's synchronous, what's happening is the following, okay? So any variables that I declare inside of here only have scope inside of this loop. So that means time seconds, file, and even current download, they only have scope inside of here, okay? And so file is the one that we want to preserve, because at the very end, we want to print out file, we want to print out this message effectively, file01.txt, but only for file01.txt, okay? And effectively, if we don't have this closure, what's going to print out instead is file 99 for all of them, which is not what we want, okay? So how it does this is the following. Because this variable file has no meaning outside of here, okay? If I try to use file outside of this loop, it doesn't make sense, okay? And that's because this set of braces, this is what guarantees the scope, okay? And then we have a function. Okay, so essentially you need some block of scope. You can't sort of do this on the global level. Okay, we have some block of scope, and then we have some, and it doesn't have to be a loop. It can be an if condition. It can be another function. Okay, but in this case, it's a loop. Okay, and then we have a function inside of here. Okay, and that function uses this file variable. Okay, this is what creates a closure. Finish download preserves our access to the variable file. Okay, it prevents it from being garbage collected. And then the next time this loop starts up, when it goes to I equals 1, a new variable file is created. A new instance of finished download is created. Okay, and that new instance of finished download preserves that instance of file. At the very end of this loop, we have 100 instances of file and 100 instances of finished download, and those are preserved. Okay. So let me change this back to synchronous before I run it to show you the difference. We're going to first run this synchronously, and then we'll run it asynchronously. And we'll see a big difference. Okay, so remember that the time for each download is going to be over here, and that's going to be up to 2 seconds. Okay, so it's going to take between 0 and 2 seconds. And let's see, so are the files starting to be created? Okay, so the files are starting to be created, 3, 4, 5. Okay, and we can see that they are in order. Okay, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6. They're being created in order, but you can see that it's very slow. Okay, I need to create 100 of these files, and it's going, again, the speed is roughly 1 every 2 seconds or so, but this is too slow for us. I'm gonna stop this. Okay, and now we're gonna run it asynchronously. Okay, and again, this means that it's gonna essentially try to download them as much as possible, up to the CPU limits. Okay, up to the operating system limits. And let me delete all these. Okay, and we're done. Okay, so all 99 files have been downloaded. Okay, so and the amount of time it took, it was, again, if I need to download 99 files, it's going to take the longest of these values. Okay, so if I can utilize all my threads, then that download took 2 seconds. Okay, and the reason, again, is because the synchronous, it occupies the CPU, and it can't do anything else until that task finishes. It sits in here, and then 2 seconds later, it'll say, okay, I can do the next one. What's the next one? Well, it's to download the next file. Whereas the asynchronous version, it'll say, okay, you threads, I'm just scheduling 100 of these tasks. You complete them as fast as you can. When you finish, execute these callbacks. Okay. And you can see that this is substantially faster. We get massive performance boosts. And now there is an issue that none of these are in order, which is something that you're kind of stuck with. You don't get any guarantee in when the files finishes in order. Okay, there's no guarantee with that. And if you want that guarantee, then you have to go back the slow way. The only way that you can guarantee it is that you do the first one, then you do the second one, then you do the third one. No other way can you guarantee that the files finish writing first, because they don't know how long these tasks take. Okay, so keep that in mind. That's going to be helpful for your assessments. That you can't. The only way, if you need to guarantee them to be order, it's not going to be a fast program. If you don't need that guarantee, if you need a different guarantee, like only that all 99 files do get written or something, that's a separate guarantee, and that one you don't need to sacrifice any speed for that. Let's go back to here. Yeah, I don't need that. Okay. Here. But again, what's allowing the correct file to be printed out is the closure that's created. It's the fact that if I go outside of here, file doesn't make sense. Whereas inside of this example, the one that we had previously with file 1 and file 2, if I go down of here, if I go over here, file 1 still makes sense. What is file 1? File 1 is this piece of code over here. If I go all the way down here, it still makes sense. It always makes sense. Okay? And that's why we get the, and so there's nothing to sort of to garbage collect in terms of these variables, so there's nothing to preserve because it's always preserved. Okay, let's see. Now, the next thing I want to do is, this works, but I don't like the amount of indentation that I have over here. Okay, there's a lot of indentation over here, and and so I need to find a way to move it out. Okay, I want to extract out this function. Okay, so I want to move this function up here. Now the problem that I have is if I move this function up here and I just call it over here with download async, the problem that I have is that this uses the variable file. And when it was inside of here, this made sense because file got preserved by that closure. But when it's outside of here, it no longer makes sense. This file, it has no idea what this is. So if I try to run this, in fact, I'll get an error. Okay, if I just run this as is, I'll get an error. And the error will say that it doesn't know what this file is. Okay, it'll pop up any second now. There you go. File is not defined. Okay, so I do want access to this file, okay, to make this code look nice, okay, but the file only makes sense inside of here, only where it's declared. So how can I solve this? Okay, and so the answer is to create a wrapper function. Okay, so the first thing I'm going to do is I'm going to create a second parameter file inside of finish download. It's going to have a second parameter. Okay, and this second parameter, it's not part of download simulator. Okay, download simulator, it has this function, when it returns back a value, okay, it takes callback and it gives us a error object. And one thing that you may think about doing is going into download simulator and changing its behavior. Okay, and this is something that you should really not do, never do. Okay, so don't go into someone else's code that you don't really understand any about it and start tinkering around with it, because you're going to break something, and that's not the actual solution. Okay, so that is possible solution, but you don't, it's not something that you want to do. Okay, so instead, what we're going to do is we're going to build a function that's called a wrapper function. Okay, and how a wrapper function works is that it takes, so this function, download async, it returns us back a function. Okay, it returns us back a function. And that function, that callback, it contains an error. Okay. And what I'm going to do over here is I'm going to call finish download from here. Okay, I'm going to take that function. Previously, we just had finish download over here. Okay, and what happened was that that function essentially it just calls this function. Okay, but this time I'm not going to assign it to be that callback. Instead, the callback is going to be this unnamed function. This is called a wrapper function, and that unnamed function is going to call finish download, and it's going to supply the error that it received. Okay, the error that it received, and I'm going to augment. This is called augmentation. I'm going to augment in this file variable. Okay, and we know that this file over here, it makes sense because this is what is preserved. This unnamed function preserves this file, and then I'm just passing it into finish download. Okay, Now this looks very similar to what I had before, where I just had the function inside of here, but I can clean this up a bit. I can make this cleaner looking. Okay, and to do that, we can use an arrow function, but you don't have to use an arrow function. If you don't like arrow function, you can leave it as is. This as is perfectly the same as what I'm about to do. Okay, so that arrow function is going to take in a input error, okay, and it's going to execute finish download. Okay, and this is the equivalence. Okay, so effectively what's happening is when download async runs, okay, after it completes the download, let's say it finished downloading file 3, okay, then it's going to get back a function, and that function is going to contain an error object, which it's then going to, this is the function that gets back, and it's going to run finish download. It's going to forward that error object, and it's also going to include the file object. And then this is correct. Okay, this is how we are able to extract out these functions. We use this wrapper function over here to forward the data along. Okay, so let's run this. And again, we create all our files, everything works. I'm going to keep you guys another 5 minutes or so I can show you the internals of what's working, and as well as run the last demo. Okay, so let's look at this again. Okay. All right, so what's happening inside of here is that we have task 1, 2, 3, all the way up to 99. Okay, we have 99 files. And the worker thread pools are taking those tasks, 3, 4, okay? It's working on them, and then when it finishes, it puts them into the event queue. So let's say that 4 finishes first, then 6, then 3, then 2, then 7, then 8, etc. Okay, so the order we don't really know, okay? And if we look at the code, okay, these are all being scheduled, okay? And then finally, the loop is eventually going to exit. So we have our main program over here. We have our main. And then inside of that main, we have the for loop, which schedules the task. It doesn't do the download. Okay, the worker threads do the download. And eventually that for loop finishes. The main also finishes. There's nothing left in the main. And then the event loop, it starts pulling out the tasks, okay? And it starts executing them. So it's going to say 4 finished, okay? So what is 4? 4, what gets returned back is this callback over here, this thing that has no name, okay? And so this has an error, and it has this file which got preserved by this loop, okay? So it has file that's preserved by our execution of the loop. And what does this function do? Well, this function, all it does is it takes that error, and it takes that file, and it calls a function finish download. So it just calls this function over here. And that's where it prints out file 4 has finished downloading. And then once that finishes, this one also is done. And then we'll move on to the next one. And it'll print out file 6, then file 3, then file 2, etc. Okay, so again, the order is not guaranteed. If you need guaranteed order, then you have to do it synchronously. And if you have to do something synchronously, then you have to delay. Okay, there's no way to avoid that. Okay. Now let's look at the last demo. Okay, so the last demo is slightly different. The idea behind the last demo is to hammer home that these techniques that we've discussed today, that they can be used in other applications. It's not just that you use them when you're downloading something, okay? In a sense, you can use this technique every time you have a task that is expensive, okay, that takes a long time to do, okay? And at the same time, you want to do something else. You can use the same technique. Okay, so I'm going to look at this file last demo. Okay. And what's going to be important to us is going to be this function shell prompt. And in fact, I need there's a tiny typo over here that I have this if statement, but I don't have an else, and I need an else. Okay, so add the else statement as well, but then it should work. Okay, so the key thing that's going to be important to us is going to be this function shell prompt. And what this does outside of it, essentially you can think about it as the following. It's like in the equivalent to C, C++, it's cin.getLine inside of a loop, inside of like a while loop or something. So essentially it's just getting the next line over and over and over again. And then every time it gets the next line, it calls the function shell prompts. Okay. So essentially I'm just continuously accepting user input. And so what is this going to do? If I type in dice/dice, it's going to roll a dice. And if I type in anything else, it's going to treat that as a file name. Okay, it's going to treat it as a file name, and it's going to run download simulator. It's going to try to download that file. So if I type in something like hello.txt or 1.txt, it's going to download that file, and it's going to pop it out inside of my files directory. Okay, so that this second part should be familiar to us. Okay, and over here it says async, but first I'm going to run this synchronously. Okay, I'm going to run this synchronously. I'm going to change it to synchronously, and then we'll run it asynchronously afterwards to see the difference. Okay. Now the only sort of limitation is because I'm using functions like process.std out.write, and I'm taking over the terminal. Okay, I can't run this inside of VS Code, not the debug console anyways. I can use a terminal over here if I want, but the font over here is too small, so I'm just going to open up a PowerShell window to run it. Okay, and so to do that, you can just right-click over here, hold the right-click works. I'll hold Shift, right-click, and then there should be an open PowerShell window here. Okay, so you have to hold Shift and right-click to get it to show up. So I'm going to be running inside of here again because I'm taking over the terminal in order to run this, and the VS Code debug output is not able to handle it. In addition, I'm going to be using a on-screen keyboard so that you can see that I'm typing in. It'll make sense in a little bit. The program that I'm going to run is Node. That's the Node.js program, and it's going to be last demo. You can type in the first couple letters and then hit tab and it'll autocomplete for you. Okay, and so I'm going to run this program, and then I'm going to start typing code. In fact, before I do this, let me bump up the time. I think it's fine. 10 seconds. 10 seconds is fine. Okay. So I'm gonna start typing 1.txt. Okay, and now I'm gonna start. So it's downloading that file, and I'm gonna start telling it to download 2.txt. But you can see as I'm typing, I get no feedback. Okay, it's sort of frozen over here. Okay, but then as soon as it finishes downloading the first one, then the second one starts. Okay, so I'm not typing anything anymore. Two starts. But I already typed in 3.txt, and it's working on 3 now. So if I say 4.txt, you can see that from a user input perspective, it looks like it's frozen. When it's not, it's actually sort of queued up by the operating system. Okay, so it's downloading 4, it's doing download. I can't do anything else during that time. So in fact, even my input that I'm typing in over here is frozen. And then as soon as it hits, then it's free. So now that everything is complete, I can download the next file. What's it called? 6.txt. And then again, like everything's frozen up. So I'm just going to hit A bunch of times over here. Okay, nothing happens. And I'm not going to hit enter this time. I'm not going to hit enter this time. Okay. So you can see that after that finishes, finally, all this input finishes. So this is how synchronous works. Because, again, we go back to this picture. This entire V8, this entire thing is blocking. It has until finished. So not even my user input that I'm typing in is showing up until it finishes. Now let's contrast this with asynchronous. Okay, with asynchronous, I just need to change this to A. Okay, and in fact, let me bump up this time to be 15. It'll still be really fast because it's doing everything concurrently. Okay. And I'm going to do Control-C to kill this program. You have to type it in twice, Control-C. And then I will run it. Okay. And in fact, this time I don't even need the on-screen keyboard. You can see that as I type in over here, that that it's scheduling all these tasks. Okay, so 1, 2, 3, 4. I typed them in pretty much similar, but you can see that I get my console back. I can start typing right away. Okay, and then when it finishes writing these files, they're all downloading concurrently. So I can do what's it 5.txt, 6.txt. I can roll a dice. I could do something else. 7. Whatever. Y.txt. Uh, I'm not locking up the CPU. I can do other things as it's putting these files. Okay, and that's the power of asynchronous programming. That you can do other things. You can roll dice. You can solve the eight queens problem. You can do other things as you're downloading these files.